Okay, so we're talking about the function f at x, which is a linear function, which means it's a straight line. There's several ways to graph it. The way that we learned in grade 9 and 10 that was easiest is this form here. M stands for your slope, and B is your y-intercept. So in other words, what they're trying to talk about there is we have our y-axis. A y-intercept is when you draw a straight line when it crosses the y-axis. So whenever it crosses the y-axis, that's exactly what you're going to be is. So say we have a straight line that goes there and it crosses at 6, our b would then be plus 6. Or if I had a line that crossed there at -3, well then our b will be -3. It's as simple like that, okay? M deals with the slope, so the rise over the run, okay? So let's say we have a line, they've given it to us that looks like, let me make sure I do this. When it's slow, it's sometimes hard to aim. Let's say that's the line. Okay, so if you notice this line, it's going to take a bit to, lines always take a long time.
Okay.
Alright, so we have a line, and it looks, there we go, something like this.
Why is it so slow today?
There we go. Hopefully it's going to start working. Yeah, there we go. Okay, so say we have a line like this.
Okay.
Finally, okay, so it's crossing the y-intercept at +9. So when I go to set this up, I already know that y is going to equal, I'm looking for my slope, x is always involved, and my b, we already know, is going to be +9. So I already know it's +9. The next thing I'm going to be looking for is the slope of a line. So I get different points. I have a point here and a point here. So I look over, from this point to this point, I go up 1, 2, 3, and over to the right one. So slope is rise over run. So we went up 3 and run 1. So it's 3 over 1. But I can actually, I don't have to write that as a fraction. That could also be written, because 3 divided by 1 is just 3, as y is equal to 3x plus 9. Okay? Does that make sense?
Yeah.
Yeah. Okay, so that's when you're doing linear ones. So try to figure out what the slope and y-intercept of that line would be. So say we're talking about a phone bill. They give us these requirements to the phone bill. It's going to cost us $30 a month for the first 250 minutes. So maybe not the nicest phone plan. But say we've made our y. And it won't be to scale right now, but we're going to say that this is 30, okay? So that's our 30 there. And we'll say that this is 250 minutes. So, for the first 250 minutes, my phone bill is $30, okay? As soon as I start going a minute over, my phone bill goes up. So let's say I was at 200 and, argument's sake, 60 minutes, okay? That's another 10 minutes. That's going to cost me another $1. So let's just say, I know this isn't to scale. We'll say that's 31. I'm now going up at this rate, okay? And it's continuously going like that. So if I need to make a piecewise function to this, I'm going to say, let's do it down here. Just want to be able to see my graph. Okay, our f at x is equal to, good. Our first part actually has a restriction because do I pay anything if I go under, if I use less than 0 minutes, so if I supply them with 0?
You don't use any.
I don't use any. So really this function is 30, because I'm paying $30, okay? If, and this is what's important. This actually is going to have like almost like a double restriction where it's 0. Oh, sorry, I should say if x. If x, or if x is less than 0, because even if I use no minutes, I still have to pay that charge every month, and less than and equal to 250. Okay? So that's that there. Now, above 250, f at x is equal to, now this line here, okay, we're paying 10 cents more a minute from there, okay? So really what I have to do is I have this point, I need to find the y-intercept of this graph. I know it's a straight line. One of my points, so one of my coordinates I know is x at 260, right?
Yeah.
And 31. And I know another one of the coordinates would be 250 and 30. So this is going to get me my slope in here. I got to find my y-intercept to get an actual equation, because right now all I have is 2 points. Okay? Do you know how to find slope? Do you remember rise over run? What they usually say is y2 subtract y1. Do you remember this at all? x2 over x1, right? So I have those here. I'm going to number them. This will be my, we'll call this x2 and y2, and we'll call this x1 and y1, okay? So this says y2 subtract y1. So y2 subtract y1, I'm going to skip a step. It's going to be 1. We know that, right? Yeah. Okay. x2 subtract x1 is going to be what? 10. Boom. So that is actually our slope. We figured out the slope is that. So I can start an equation, and I'll start it below, just because we're not quite sure what it is. We know it's going to be y equals mx plus b, okay? And we know our m, we've just discovered it. 1 over 10 is our m. So y is equal to 1 over 10 x plus b. Now, we don't know what b is right now, because this, you're right for the piecewise function, right? It's 30. But this is a continuous line. We just have a restriction on it, okay? So this line is going to come across, and I got to figure out where it's going to hit the y-intercept. Okay? So what I'm actually going to do is I'm going to plug in one of my x values and one of my y values. And I'm actually going to use these two because they're round numbers. 250 and 30. So that's my x and my y value. I'm going to plug them in to solve for b. So we know one of the coordinates was 250 and 30. Okay? I'm going to plug 250 in for x and 30 in for y, and then solve for b. So I have 30 is equal to 1 over 10 times 250 plus b. Okay? From there, I just have to work out the algebra. So I get 30 is equal to, this is going to be 250 divided by 10, which will actually be 25. Okay? Plus b. When I move 25 to the other side, what am I going to get? Which is 5. So b is 5. So my actual equation, when I go to put it in here, remember this is our y, is equal to, I could put 0.1x or 1 over 10x. 1 over 10x plus 5. That's the actual equation for the second part of the piecewise function. And then I have to give it this restriction. If, and that's when x is greater than, not equal to, 250. Does that make sense?
Yeah.
So we actually had to figure out the slope and y-intercept of that straight line. Okay. So we have a function like this. Your first step was great. Let's actually, I'm going to put a line right down where our restriction would be, which is at -1. Okay. So my restriction is there. My restriction's all taken care of. I have a straight line that intercepts at -1. The slope is up to over 1. So the opposite way would be down to over 1. So I know I'm touching here. And again, I have some line that does that. Okay?
Mhm.
Stop using lines. Slow it down. Okay. So, our line goes like that. Now we know normally a parabola, and I'll do it in red to start, just to say. Our vertex is here.
Yeah.
We go over 1, up 1, over 2, up 4. But lucky for us, all they want is a k movement, right?
Yeah.
So that means we're moving up and down. So we're not stretching the parabola at all. So essentially, if I move down, let's say 2, my parabola over 1, up 1 would touch here. Okay?
Yeah.
So if I move down to 3, over 1, up 1, it touches here. Where do I need my parabola to touch?
On that.
This spot here. So I need to go down how many?
4.
4. So if I'm at -4, technically my parabola, and I'll do this part in red. If it was here, we go over 1, up 1, and from there. So the red part will be the imaginary because it's not technically part of this graph. And then the black part will actually be the extension of this graph. Okay? So extension of this graph should be, now we go over 2, up 4. 1, 2, 3, 4. Over 3. 1, 2, 3, up 9. 1, 2, 5, 6, 7, 8, 9. So, we have those points. Technically, the black part is the extension of this line. I'm going to get rid of all the other red things. Okay? The black part is the extension of this line. The red part tells us where the vertex would be, but this line needs to look like that. So because our vertex needs to be at -4, that means our k value needs to be, well, they've already given us a negative value, so technically k is 4, but you could say the vertex is at -4. Okay?
Thank you, sir.
Does that make sense?
Yep.
All right, let's save this for you. I'll print that stuff.